So welcome back to the continuation of our tutorial series on deploying a machine learning model on Kubernetes. So far we have tested our API endpoint. So let's containerize our application. Okay. So Docker and Kubernetes work together to create a scalable, portable, and efficient deployment for application. So including like machine learning model and APIs. So Docker will package the application and the dependencies into containers, so ensuring they run in the same way in any environment, whether it is development, testing, or production. So our Docker image is here in this file, and with this Kubernetes orchestrate and manages these containers across multiple machines and making it like easier to scale and maintain. So without Docker, Kubernetes would need to like handle dependencies manually, which will leading to like inconsistency across different environment. For in our case, FastAPI based ML models can be like containerized with Docker and deployed consistently across cloud or on-premise Kubernetes cluster. So in our case, it just allows scalability and load balancing, as an ML model inference API can scale from like 1 to 100 containers in response to like high traffic without downtime. And also it allows ease of like deployment and CI/CD integration. Like every time a new ML model version is trained, Docker image can be built and deployed to Kubernetes cluster automatically. And then also efficient resource utilization, because a Kubernetes cluster running multiple ML models in separate Docker containers maximizes the GPU and the CPU utilization. And then it also allows the fault tolerance and high availability. So if a machine learning model container crashes, so Kubernetes will automatically restart it without any manual intervention. And also it just helps in service discovery and networking, as a fast API model inference service is running in Docker, which can be like accessed by another containerized data pre-processing service via Kubernetes like networking. And then it also helps in security and isolation, as different ML models, like if you are deploying like fraud detection, NLP, or computer vision model, that can run in an isolated Docker container with a specific permission. So let me give you the walkthrough of this Docker file that we have done so far. So this Docker file, which defines the lightweight containerized environment for deploying a post API based machine learning service. For the first line here, if you see, so from which will specify the base image, which is like Python 3.0 in our case, and the variant of Slim. And Slim version, it's a minimalistic version of the Python image, reducing the container size by removing unnecessary system libraries. And we'll be having our work directory app. So work directory slash app, which this is the command, sets slash app as the working directory inside the container. All the subsequent commands will be executed from this directory. And then we are having like a copy requirement.txt. We just copy the requirement.txt file from the host machine into the container. And then we'll be having our run pip install requirement.txt, which just installs the required Python dependencies inside the container. And we have mentioned like no cache directory here, so it just prevents unnecessary caching and reducing the image size. And then we are having copy source slash app slash source. So this copies the source directory, which contains the ML model and API code from the host machine into the app slash source directory inside the container. And this ensures the fast API application and model files are available inside the container. And then we have expose 8000. So this declares that the container will listen for the request on port 8000, and this is the default port for EVCon used to like serve the ASGI server used to like serve fast API application. And then we will be having, so this command will be executed when the container starts. So basically EVCon, if you see, it's a ASGI server that runs the fast API application, and we'll be having our source API main.app, which specifies the location of the fast API application. And here we have our host, like which will allow the service to be accessible from any network interface, so that we are having like 0000. And then we'll be having the port 800, which runs the service on the port, on the specified port. So now let's build the image. Let me open the setup file side by side. So as I mentioned earlier, we'll be using Podman instead of Docker. If you are like using Docker, no problem. Let's just try with the same command instead of like Podman. So let me build an image with the name ML demo. So ML demo with the tag latest. So basically we are building a new Docker image from the Docker file which is found in the root folder here, which is the one you see here. So we see like so Docker image is built successfully and it's tagged as latest. So once we run with it, we have to run the Docker container locally to test like whether it's working as we wish. So now we build our image. So once our image is available, let me open the Podman here. We have just created an image. So let me go back to the VS Code here. So now it's time to run our Docker container locally to see whether it's working as we wish. For to do that, let's do Podman run with the name of the image. So here if you see like port 8000 which is inside the container, this will map to the port 800 on the host machine. So this will allows you to like access the FastAPI services locally at localhost with the port 8000. So let's run it. So the application is currently running. Let's test it. You can test it by just going here to the localhost 800. So whether you can test it by checking the health. For example, let me do. So it's just saying it's healthy and we can see like 200 here. So let me send another request here. Okay, so we are getting the prediction. We can also test our metrics endpoint. Okay, great. So model prediction total with our application which is running as a container is 1. So you have just tested the endpoint once. So just it returns 1 as a model prediction total. So now it's time to like push our Docker image into the registry. You can use cloud-based registry as well, but for this walkthrough we'll be using Docker registry that I have created earlier. So before start to push your image to the public repository, so we need to configure our Docker Hub in Podman. So for to do that, you can go to here to the setting and then registries. And here if you see, I have already configured the Docker Hub with my username and password. So in order to do a write to push an image to a public repository or even a private repository. So let me do Podman tag, the name of the image with its tag. We'll be pushing this to the Docker repository that I have created earlier. So I will go into this registry to walk you through as well. Sorry, let me tag it, and now it's time to push it. So let me go to the Docker Hub from here. Let me sign in. So you see like we have just pushed an image. So image is available here. Okay. So we can use like Docker Hub, AWS ECR, or even like Google Container Registry to push the Docker image to the registry to test this application. So far we have tagged our Docker image and we have pushed it to the registry. And Docker Push just uploaded the image to Docker Hub and making it available globally as it's a public repository that we have created with Docker Hub. And now it's time to like deploy this image with Kubernetes. Successfully trained our model and we have just saved the model in disk and we have tested the model locally by using the FastAPI endpoints, and then we have just built a Docker image with this FastAPI application and we have tested this locally as well, and we have pushed this image as well to the Docker Hub registry, and now it's available globally for to deploy with Kubernetes. And it's time for Kubernetes deployment. So let's see you all there.